Tips and tricks on how to plan intervention design in view of future counterfactual impact evaluations. This video tutorial provides ideas on the design of labour market interventions in light of future counterfactual impact evaluations. These ideas are similar to a magic box. Some little practical precautions can make a big difference in an intervention, making it amenable to CIE. These practical precautions that can work magic are called tricks in what follows. Along the way, the video also gives hints, called tips, to the appropriate CIE method to apply. Note, however, that in order to understand how methods work, you'll need to resort to some of our other videos or guidance book on CIE. Some tricks work best in certain situations. The video lists some typical situations where tricks can be applied. This list of situations is by no means exhaustive, as many other variations can occur in practice, possibly in combinations. This is one reason to have a CIE expert in your team. The take-home message of this video is, always think about how to create a comparison or control group. This is not so difficult. Remember, one speaks of a treated group, typically the group of individuals who benefited from the intervention, and a control group, a group of individuals who did not, but which is comparable to the treated group. The first powerful trick in the magic box is randomization. This means selecting one unit among a group using a chance mechanism, like throwing a dice or flipping a coin. Here is an example of how this trick can be used in designing the intervention in view of future CIE. Example 1. In the 1970s, the Manpower Demonstration Research Corporation launched the National Supported Work Demonstration. The aim of the intervention was to provide evidence of the effectiveness of the job training programs for women with dependent children, ex-drug addicts, ex-criminal offenders and high school dropouts. People in one of the previous categories had to apply for the intervention. This created the treated group, those randomly selected, and the control group, those not selected. Both groups were similar because they'd applied for the program and only differed by treatment assignment. Participation was randomly assigned among the applicants. The selected participants received from 9 to 18 months of paid supported work in order to learn a new skilled job and to improve their abilities. Comparing the average employment rate of the treated and non-treated control group 6 months after the training, one obtains an estimate of the average treatment effect. This is an example of a randomized control trial. In this case, the trick is randomized treatment. This is expected to work because the two groups formed by randomization are similar, except for one of them being subject to the intervention. The analysis of results, i.e. the CIE method, is very simple in this case. Tip: compute the average treatment effect as the difference between the average employment rate of the treated and non-treated. The above example also gives a typical situation where the randomization trick can be applied. Typical situation: when you have oversubscription of a certain intervention, you may allocate available slots via randomization. Here, oversubscription means that there are more applications than available slots in the intervention. Random assignment sometimes coincides with giving everyone equal opportunities, i.e. a fair chance of treatment. Other times, randomization may be less attractive. For instance, it may be judged unsatisfactory to leave some of the applicants untreated. In this case, one can resort, for instance, to a phase-in design. Here is an example. Example 2. Assume that a new voluntary training program for unemployed needs to be rolled out in 20 municipalities in the same region. Because there are a limited number of trainers, the intervention needs to be implemented in several phases, providing the training to unemployed people in only 10 municipalities at the same time. At time 1, there's going to be one wave, and at time 2, a second wave. How to select the 10 municipalities for the first wave? A fair way is to select municipalities at random. In this design, the first wave will contain 10 municipalities, Group A, and the second wave will contain the remaining 10, Group B. The idea of phase-in design is to use the data on the treated unemployed people in Group A at time 1 as the treated group, and data measured at time 1 on the unemployed people who've registered for the program in Group B as a control group. Note that at time 1, Group B is still untreated, so it can act as control group. As with the analysis of an RCT, the ATE is estimated by comparing average employment rates of treated and controls. In this case, the trick is randomized time of treatment. This is expected to work because randomizing the time of treatment is the same as choosing who receives training at time 1 by random assignment. The analysis of results, i.e. the CRIE method, is still the same. Tip: compute the average treatment effect as the difference between the average employment rate of the treated and non-treated. The typical situation is when one has that all applicants need to be treated, but at different times. In example 2, note that everyone is eventually treated, but that the intervention can still be evaluated. In some situations with oversubscription, it may be deemed appropriate not to use randomization for assigning treatment or time of treatment. Rather, the idea could be to favor the applicants most in need. The following example shows how this can be done in a way that allows future CIE. Example 3. Assume the same setup of example 1. Assume also that priority needs to be given to poorer applicants. For this, a yearly income indicator is constructed, using equivalent scales for the size of the family. The administration decides to include in the treatment group all the families with an income lower than €250 per person per year. Here, the treated group is defined as all individuals with an income indicator lower than €250. The outcome of interest is the employment status 6 months after training. How can one construct a control group in this case? One idea for constructing the control group would be to use the applicants with income indicator falling just above the threshold of €250. They are comparable to the treated people with income indicator falling just below the threshold. The CIE comparison in this case would be between the average employment rate of treated people just below the threshold and the one of untreated people just above the threshold of €250. The CRIE method in this case is called Regression Discontinuity Design, or RDD. In this case, the trick is allocate treatment on a basis of a score with a threshold. The score or forcing variable is a quantitative, continuous, observable variable, like income in our example, but also age or unemployment duration would be other examples, or a function thereof. The threshold must fall in the middle of the distribution of the forcing variable, because you need both treated individuals and people in the control group. In our example, the treated group could be taken to be applicants' yearly income indicator between €230 and €250, and the control group those with yearly income indicator between €250 and €270. Make sure to collect data both for units above and below the threshold. This means collecting data also on non-participants. Use the threshold, in our case income, from the eligibility condition in the RDD analysis. RDD is expected to work because it works similarly to a randomization around the threshold. The analysis of results, i.e. the CIE method, should be done with RDD. Tip: regression discontinuity design. The typical situation is treatment assignment is a function of income, age, unemployment duration with a threshold. RDD estimates impact close to the threshold. For example, considering the example above, assume that we arrived at the RDD estimate of plus 0.05. We can conclude that the job training program has increased the probability to find a new job by 5% for the individuals with an income indicator slightly less than €250. However, this gives no information about how the treatment affects individuals far from the threshold point. RDD is an example of a quasi-experimental method. These are defined as the class of methods that try to mimic randomization. In the case of RDD, the method relies on a local randomization around the threshold. Here is another example of RDD. Consider the case of a training intervention targeted at young unemployed, aged 28 or less. This might be the case of a youth guarantee intervention. Age is one of the determinants of employability, in addition to being used as a forcing variable to select participants. One idea to estimate the effect of the program is to compare the average employment rate of unemployed people participating in the program that are just below the age threshold with the average employment rate of unemployed people just above the threshold and who are therefore not participating in the program. The rationale for this is that people just below or just above the threshold face similar labour market conditions and hence make up a good pair of treated and control groups. Also, the data coming from this quasi-experimental setup can be analysed with regression discontinuity design, or RDD. As shown by the previous examples, one can design an intervention where the eligibility rules define the treated and control groups. Again, in this case, the trick is allocate treatment on a basis of age with a threshold. Use age and its threshold in the RDD analysis. The reason this trick is expected to work is that RDD works as a local randomization near the threshold. The analysis of results, i.e. the CRIE method, should be done with RDD. Tip: regression discontinuity design, or RDD. The typical situation is treatment assignment is a function of age with a threshold. Assume now you're in the situation where some regulation or intervention applies to some region but not to others. The idea in this case would be to use the specific regions unaffected by the intervention as a control group. In order to control for region-specific characteristics, it would make sense to use changes in unemployment rates as shown in the following example. In Germany, Land A implements a program aimed at fostering the employability of unemployed people aged 55 or more. This is not the case in the Länder B, C and D. Therefore, residence and age determine the eligibility of people for the intervention. In this case, the treated group consists of the unemployed people aged 55 or more in Land A, and the control group is made of unemployed people aged 55 or more in Länder B, C and D. If the Länder A as well as B, C and D are exposed to the same institutional or environmental changes over time, except for the exposure to the intervention, one can assume that, without an intervention, the employability should follow similar trends in Länder A, B, C and D. This assumption is called the parallel trend assumption. Under the parallel trend assumption, the estimation of the ATE is obtained by subtracting the average change in the outcome for the control group from the average change for the treatment group. This method is called difference in difference. In this case, the trick is observe individuals in regions affected by the intervention, the treated group, and unaffected, the control group, at consecutive times before and after the intervention. Check that the data for the outcome of interest, employment status, wages and so on, in the pre-intervention period are available and that they're collected in a homogeneous way with respect to the ones collected for the post-intervention period. Administrative data could provide useful help. Additional pre-intervention information could also improve the reliability of the method by checking the parallel trend assumption. Check the availability of additional pre-intervention information. This is expected to work because treated and control regions are subject to the same environmental factors, common trend assumption, except for the treatment itself. The analysis of results, i.e. the CRIE method, should be done with difference in difference. Difference in difference. The typical situation is that the treatment is implemented just in some region and the outcomes are collected for this region and others before and after the intervention. The main advantage of difference in difference is that it lends itself to be used in a variety of situations, provided that it's possible to collect the outcomes in a homogeneous way before and after the intervention. As seen so far, there are numerous tricks. Some of them are easy, some are not so easy. The most difficult trick is introduced in the following example. As all other methods, this trick is very useful, so please pay attention. Example 6. Let us consider a region that wants to introduce a policy for supporting disadvantaged families. Only families with a household income lower than a certain amount are entitled to receive the benefit. Moreover, the potential beneficiaries have to ask for the subsidy with a formal request. The outcome of interest is the probability of disadvantaged families to send their children to school. The regional authorities decide to encourage potential participants to apply by sending an encouragement letter to some of them. This letter aims to promote and explain all the details of the intervention. Because the potential beneficiaries are too numerous, the region decides to send the letter to a subset of them. The region happens to have a smart CRIE expert who suggests selecting the recipients of the letter by random assignment. This letter is called the intention to treat, and it technically generates a so-called instrument. The randomization of the instrument is very important. The instrument needs to raise the probability to participate, but be otherwise unrelated to the fact of sending children to school. The results of the intervention can later be analyzed by a technique called instrumental variable. This strategy works if the letter has made participation to the intervention more likely for its recipients. In this case, the trick is, in our example, randomly sending an encouraging letter represents a valid and relatively non-expensive strategy that will allow evaluating the intervention by means of instrumental variable. More widely, there may be several available instruments. They might be linked to environmental and institutional exogenous factors. Instruments are variables that are not directly under the control of the individuals, but can affect their participation in the intervention. Examples are exposure to different information channels, proximity to the place in which the intervention is carried out. And in example 6, this exogenous factor is the encouragement letter. Do not forget to discuss about potential instruments with the evaluator. She or he will be able to select which one could be used. Instrumental variables is expected to work because the instrument generates randomization type effects on the treatment. The analysis of results, i.e. the CRIE method, should be done with instrumental variables. The typical situation is there is some exogenous, i.e. external or pre-existing factor that affects the outcome of interest, employment in this case, only by increasing the likelihood of individuals to select treatment, i.e. to participate in the training. In the example, the external factor is receiving the encouragement letter. Instrumental variables could be easily designed before the intervention. For instance, as an invitation letter is a good instrument, then instrumental variables is easy to be implemented. The method allows to estimate the effect of the individuals that change their decision to participate to the intervention according to the letter. For this reason, the identified effect is called the local average treatment effect. We are now towards the end of the magic box. The last trick of the trade is introduced in the following example. This trick is kept to last because it requires large data sets, such as the ones available if you have access to administrative data sources. Example 7. Consider a voluntary training program for unemployed aimed at increasing employability. Individuals registered in an employment office have to choose if participating or not in training programs. The employment registry holds many pieces of information on individuals, such as age, gender, and past work history. In this case, the treated group is the one that has received training. In order to form a comparable control group, one could select from the population using administrative data a sample of similar individuals in terms of age, gender, work history, and so on. This method is called matching. In order to define a proper control group, one needs many variables before the intervention to use for matching. This is why this method requires a lot of data. Matching can be done via a single score, called propensity score, that summarizes all individuals' characteristics that affect the probability to participate. The average treatment effect for treated people comes from the difference between the average employment rate 6 months after training of the participants and the one of the match controls. This is called ATT. Note that ATT differs from ATE. ATE is the effect on the whole population. ATT is the effect on the treated part. In this case, the trick is match participants with similar non-participants. Matching could be applied more or less in every situation, in particular when the participation to the intervention is voluntary. Therefore, do not a priori exclude it among the possibilities. The two crucial elements that make matching successful are the availability of pre-intervention data on which one can match individuals and of a large control group. In more detail, matching methods allow identifying among the control units those who are the most similar to the participants. The disadvantage is that potentially a big fraction of units in the population may be excluded from the analysis if they are not comparable with the treated units. For this reason, make sure to provide to the evaluator a control group that's much bigger than the treatment group to be used to select the control group. The credibility of the matching results strongly depends on the pre-treatment information that is included in the analysis. Collect as much information as you can for both treatment and control group. Past work histories, demographic characteristics, and household information could be a good starting point. It is very difficult to find large enough information from a survey data set. Check the availability of administrative data, in particular for work histories, to link to the available survey data. They are probably available. Matching is expected to work because treated and matched individuals have the same characteristics except for the treatment. The analysis of results, i.e. the CRIE method, should be done with matching, like propensity score matching or PSM. Matching, such as propensity score matching, has the following typical situation: access to administrative data and/or the collection of large pre-intervention information that may influence the decision to participate in the intervention, in addition to data on the outcome of interest. Summing up, the take-home message of this video is to use foreseen and unforeseen characteristics of the policy intervention to create an appropriate comparison or control group. In particular, there are several typical situations that prompt the use of a specific class of CRIE method. For example, if the eligibility criteria involve a threshold, think of RDD. If some regions or geographical clusters have been subject to treatment and others have not, then think of difference in difference. If some encouragement letter was used, an intention to treat, the right method could be instrumental variables. And if you have enough information to properly model the selection into treatment by propensity score matching, then PSM is probably for you. Not all methods are applicable in a single intervention. One needs to find the right one or ones. Different methods estimate different kinds of impact, for instance. RDD estimates the impact for individuals at the threshold. For example, would evaluation questions like, what is the impact of the training on employability for individuals who earned slightly more than €250 last year, say €256, and hence they were not eligible, and those who earned slightly less than €250 this year, say €247, and hence they were eligible for treatment and have been treated. PSM estimates the ATT. For example, it would fit evaluation questions like, what is the impact of a training program on employment for unemployed individuals in a group with the composition of sexes, age and education equal to the one of the treated group? Difference in difference estimates the ATE. For example, it would fit evaluation questions like, what is the impact of a training program on employment for treated regions? Instrumental variables estimates the LATE. For example, it would fit evaluation questions like, what is the impact of a training program on employment for the compliers subpopulation, i.e. for people who decide to participate due to the encouragement letter? Which impact do you need? Choose which impact you think it is most appropriate for your intervention. When designing the intervention, you should pave the way for the application of 2 or 3 methods with their associated impacts. In this way you will save money because you can plan the collection of the right data from the start and have reliable results because the intervention design is suitable for the application of the CRIE method. CRIE methods can be combined and refined to fit special situations and purposes. A CRIE expert is like a medical doctor who needs to find the right medication method for the disease at hand. She or he may need to apply a combination of medications. Who would cure oneself without consulting a doctor? So we suggest you reserve some dedicated time for a CRIE expert. A list of CRIE experts can be found at the following webpage. Overall, and in all the above situations, it may pay to consult some expert in CRIE methods when designing interventions, selecting a contractor, or doing the analysis. Thanks for watching. If you wish you knew more about CRIE methods after watching this, then follow our videos on the YouTube CRIE channel.